Hi, Steve here at the SJCOE Fab Lab, and we have some neat stuff here that we're going to use to work with shadows. Now, shadows in geometry is a time-tested, just a great lesson. I remember fondly learning about shadows and similar triangles when I was in high school a while ago. And I remember when I taught geometry, I taught the same lesson. It was a very long time ago as well. Anyway, we're going to do this great lesson, but with a little bit of computer science, and it's going to be a lot of fun. So let's get started. I'm just going to introduce you right off the bat to how this ties into computer science, because you might be a little bit surprised. After all, we're not going to program. But computer science, it's not just coding. Coding is a part of computer science, but it's not all of computer science. So let's put up our graphic right here. Computer science has 5 areas. Computer systems, because all computation occurs on a physical system. Networks and the internet. Algorithms and programming, that coding that we always think of for computer science. Data and analysis, which is going to be one of our key foci today. And impacts of computing, because the students are learning to code, they're making computational artifacts, they're becoming engineers, and we want them to make solutions that help people. All right, so what standards are we going to be dealing with today? Let's go over them. 912 CS1 describe ways in which abstractions hide the underlying implementation details of computing systems to simplify user experiences. That's going to come in handy because we actually want the kids to think a little bit about the fact that they're going to be taking some photos, and the photo might not fit up on the screen perfectly with what they graph. And it's a chance for students to think about the fact that when they take a photo with, say, their camera, since, well, not just camera, their phone, which is a camera, since using that phone is the main way that photos are taken nowadays, well, if you have an iPhone, it's got more than one camera on it. And what's going on is that there's some calculations going on inside of the phone to figure out what the best photo is. Now, this system hides away a lot of that. You just aim and you take a photo, and you don't say which camera you want it to take it with. You don't tell it what algorithm to use to process to make sure you got the perfect photo. Let alone sometimes you can just add a filter or remove something that you don't want in the shot. A lot of the difficult math necessary for that is abstracted away. And it's a chance for students to think about how computers are made simpler through this. Our next standard, and our next couple of standards, are not going to be computer systems. They're actually going to be data analysis. Remember, it's kind of focusing on data. 912 DA10, create data visualizations to help others better understand real-world phenomena, like the shadow. And 912 DA11, refine computational models to better represent the relationships among different elements of data collected from a phenomenon or process. All right, so what the students are going to be doing is using an online graphing calculator called GeoGebra. They're going to gather data about their shadows that they measure and observe. And then, well, they're going to gather that data into a visualization and a presentation to share with their group. All right, let's continue. So the last thing we want kids to do is think about how they collaborate. So they're communicating, they're collaborating. 912 AP21, design and develop computational artifacts working in team roles using collaborative tools. So the students can work together using something like a Word document in order to share data that they gather from different objects where they're taking the shadow, to share tables of information, to share the image that they create with GeoGebra, and work together in order to create their explanation of what's going on. All right, let's move on to talking about GeoGebra. This tool that you might not have used, but maybe you have. Either way, it's a chance for the students to learn a new tool and get to look at math a little bit differently. Let's take a look at GeoGebra. It's a graphing calculator. Notice we can just use it like a scientific calculator. Let's try that out. Let's say I wanted to calculate 6 plus 5. Oh, well, that's great. Here's another thing that I can do. I can set the value of a variable. Like saying u equals 12. Now, notice something happened there. I get a slider. So I can adjust the value of my variable u. I also can hit play to have it run through all the possible values. That's handy. All right. Let's try something else. I'm going to make a value that is equal to something calculated from u. Let's say that L looks like 1, so let's try something else. B equals u plus 4. Now when I hit play, notice that the value of B is changing because the value of u is changing. In fact, we can even graph, like we would with, say, Desmos, and say f of x equals 2 times x plus u. All right, now if I play through all the values of u, notice how my graph is changing. Pretty cool. All right. Now, what this will allow us to do is to gather a little bit of data and very easily plot it right here. Now, students will go outside and gather some shadow data, but for ease of making a film with a single camera, I figured we'd just do this here. So it's pretty bright. We're going to cast some shadows. Notice shadows do show up from this light. In fact, I can see the shadow right there. Let's measure. All right, let's gather some shadow data. Now, I've put down this tape to make sure that I'm always measuring from the same point. Otherwise, it'll throw off our shadow and throw off our data. Okay, let's try it out. I'm going to start with just this block here. And I can see the shadow goes to right there to make my measurement a little bit simpler. So I can say, all right, well, 2.2 is the height, sorry, is the length of the shadow, and 1.5 is the height of the object. So 1.5, 2. we're going to make the height of our object x and the length of the shadow y. Okay, let's keep going. I'm going to have another object. One, two, three. All right. Okay. So I can see my shadow. See it right. Okay, so, it's exactly 7 centimeters. It's the length of the shadow. And from there, say 4.6. Okay, let's try one more. Now what I want to do is add in a photo. So you can go to Tools, Image, and I already took a photo, so I'm just going to go ahead and add it in. You might notice it looks a little bit different. I took it from a different angle. It helps for this type of thing, so that the angle would be, the shadow would start at the origin. Now you'll notice, not too shabby. Our line is kind of along the line of sight. Now, what students are going to be doing is trying to make a case for how tall something like a flagpole is in the distance. And what they can do is just this exact type of work: observing shadows, measuring shadows, plotting. Now that students have added in their photo, they can make a case for what they've observed. Remember, they're measuring something in the distance, something large, and they're making a prediction about how big it is. And they're going to make the case for how big it is using what they've measured and illustrated right here. So, one other great thing students can do is add in polygons. If you don't see it immediately on your screen, you can click on More. Polygons is a little bit lower. And I could do something like make a triangle right there showing the shadow. I could even add all the points together, show that they're similar triangles. All right. I hope that your students enjoy working with GeoGebra. I hope they enjoy getting outside and seeing the math that's in the world around them. It's a fun activity. It's memorable. Have fun.